Hello, this is the luckiest maths teacher in the world. Today we're going to look at mental strategies for arithmetic, which basically means I'm going to give you some methods you can use to do multiplication and addition in your heads. Now first, we're going to look at the laws that we did last lesson. So first, remember we looked at the associative law, which basically means we can put the brackets wherever we want if there are more than two numbers. So for addition, for example, we know that if we have, say, 2 plus 4 plus 5, we get the exact same answer if we put the brackets around the first two. If we get an answer to the first two, then add the third, it's the exact same answer as if we add the second two numbers and add the first. You get exactly the same answer, okay? So we're going to use that in mental arithmetic. Now it's very similarly used to the commutative law. So if you don't remember that, that is basically that the order of numbers doesn't matter. You probably already knew this without actually knowing it before you were told what commutative means. For example, we know that 3 times 4 is 4 times 3. The order in which we multiply or add things doesn't matter. We get the same answer. So what's this have to do with mental strategies? Well, we can actually use these laws to make mental calculations easier. Now, what we do when we're using either of these laws, we use them when we have 3 or more numbers, and we basically rearrange the order in which we calculate something. So I'll give you an example of this. Let's say we have to do something like this. Let's say we have to do 89 plus 68 plus 11. Now, a lot of people in the world, they'd have trouble doing 89 plus 68 efficiently. So don't feel bad if that freaks you out a bit. But in this case, we could use the commutative law to move the numbers around to make it easier. So what you might notice is that 89 and 11 add up to 100. So if I rearrange the order of these, which again I can do, I get 89 plus 11 plus 68. Now that is actually much easier to do because 89 plus 11 is just 100. So it's just 100 plus 68, which is of course equal to 168. Okay, so I was able to do that so much quicker by changing the order in which I added things. So you can do that for addition or multiplication. Now I'll show you an example where we use the associative law. So let's say we had something like, 86 times 5 times 2. See, a lot of people may find 86 times 5 challenging, or even if they can do it, it might take them a while. But remember, because we have two multiplications here, we can put the brackets wherever we want. So we could actually put the brackets here. What I'm essentially saying is we could multiply the last two numbers together first. Now, you probably all know that 5 times 2 equals 10, and multiplying by 10 is really easy. So instead of trying to figure out what's 86 times 5, I could actually just do the 5 times 2 first, and this becomes 86 times 10. That's really easy. When you times something by 10, a whole number by 10, you just add a 0 to it. So I get 860, okay? Nice and easy. Now I'll show you an example involving the distributive law. So the distributive law is a bit different. As you saw in associative and commutative, what I do is basically change the order in which I multiply or add numbers to make a number that's easier to deal with. Now with the distributive law, we are actually going to change it to something that's easier to deal with, but we're going to do it in a different way. Now you can use the distributive law when you have only two numbers that you're adding or multiplying. Okay, so just a quick recap of what the distributive law is. I'll just give you a numerical example. So remember, if we have 4 times 5 plus 3, we've done order of operations. So we have to actually add the numbers together first. But what we can do is we can expand this and know that it equals 4 times 5 plus 4 times 3. Okay, so distributive law comes from the fact that we distribute the 4 to everything inside the brackets. Okay? So how does that help with mental calculations? Well, let's say we have something like this. 89 times by 11. Okay, so multiplying by 11, especially multiplying a number like 89 by 11, it isn't the easiest thing to do. So what we're actually going to do is find a number that's easy to work with. Now the number 10 is easy to work with, okay? It's no coincidence that I chose 11 here, because when you have a number that's close to 10, you can write that number in terms of 10. Now you're probably thinking, whatever do I mean? Well, what I mean is, we'll leave the 89 as it is, but because 10's easy to work with, we write that 11 as 10 plus 1. Okay? Again, I chose 10 plus 1. I could have written this as, 8 plus 3, but I wrote it as 10 plus 1 because 10's easy to work with. Now, using this distributive law, that would just equal 89 times 10, which is very easy to do, plus 89 times 1, which is very easy to do. So, 89 times 10 is 890. 89 times 1 is 89. So I just add them together. So 890 plus 89 is 979. Okay, that didn't take me too long. That's a lot quicker than trying to figure out 89 times 11. Okay, I'll do another quick example with this. So let's add to do something like this, 131 times 8. Now again, we might think, okay, multiplying by 8 is not the easiest to do, but multiplying by 10 is easy. Now, 8 is close to 10, so I'm going to use the exact same trick. I'm going to write 8 in terms of 10, as 10 plus something or 10 minus something. So obviously, 8 is actually 10 minus 2. So I can write it like this. Again, I chose 10 because 10's easy to work with. And 8 is 2 less than 10, so 8 is the same as what's in the brackets here. So then what I do, I expand the brackets, so I distribute the 131 to everything in the brackets, so that'll be 131 times 10 minus 131 times 2, okay? 131 times 10, nice and easy, just add a 0 to the end. 131 times 2, people generally good at doubling. So this is what I have here, 1310 minus 262. Okay, now I'm not going to lie, sometimes when you use these mental strategies, you still have to do something that's a little bit tricky, but I think that 1310 minus 262 took us almost no effort to get there, and I think it's way, way easier to do that subtraction than it would be to try and figure out what 131 times 8 is another way. So I just figure out what 1310 minus 262 is, okay? You can do that any way that you want, but any way that you do it, you should get an answer of 1048. Okay, so I'll just show you a few more strategies. So powers of 2 is a strategy we'll use when multiplying. So first we have to know what a power of 2 is. Well, we did powers, so that means it's just 2 times 2 a certain number of times. So powers of 2 are numbers like 2, 4, 8, 16. So this is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and so on. Okay, don't worry, you won't need to know all the powers of 2 for this one. Okay, so how do we use this in calculations? Okay, well, let's say we're multiplying, power 2 by, say, 31. So people are generally good at doubling. So 31 times 2, that's easy. You just double it. But if you wanted to do 31 times 4, because 4 is 2 times 2, you just double 31 and double it again. So if I double 31, I get 62, and if I double it again, I get 124. How easy is that? If I want to do 31 times 8, because 8 is 2 times 2 times 2, then I just double the number 3 times. So I double it once, I get 62. Double it twice, I get 124. So if I double it again, I get 248. And as I'm sure you guessed, if I want to do 31 times 16, I just double that again. So if multiplying by 4, double the number, double it again. Multiplying by 8, double the number 3 times again. Doubling is something people usually find easier, well, much, much easier than, say, multiplying by 8 another way. Okay, last strategy. Okay, so the last one I'm going to show you multiplying by 5 or 20. So these calculations can be made easier because one of them is a factor of 10, one of them's a multiple of 10. And as I said, multiplying by 10 is really easy. So let's look at something like 42 times 5, okay? Some people might try and, add up 42 5 times. It takes a little while. What you can do, though, is you can multiply it by 10 and then divide by 2. Okay, because 10 divided by 2 is 5. Because of order of operations, we can do that. So, 42 times 10 is easy. It's just 420. Whole number times 10, just add a 0 on the end. And then we need to divide that by 2, and most people can do that easy. 420 divided by 2 is 210. So when multiplying by 5, multiply the number by 10 and then halve it. So that's almost the same as when we're multiplying by 20. So if we were multiplying 42 by 20, we still do 42 times 10. But 20 is not 10 divided by 2, it's 10 times 2. So we write it like this. Okay? This works again because of the associative law. I can do it like this. I can put the brackets there. Okay? So excuse me. So, to figure this out, first we multiply by 10, so we're going to go 42 times 10. Again, that's really easy, 420, and then times it by 2. People are usually pretty good at doubling. And then you get 840, okay? Now, I know you might be thinking, oh my god, there's so many strategies to remember, but they are all on the sheets that I gave you. You can refer to them anytime that you need, okay? So other than that, have a wonderful day.